Hello everyone, this is Vishwesh, and in this video we are going to talk about the first topic of quantitative aptitude skills. The name of the topic is number series. So in this video, in this topic we are going to talk about the number series problems. Here you can see, and their types. Then we are going to talk about strategy to deal with these number series problems, and we will be practicing few questions, and I will try to provide lucid solutions for those problems. And at the end of video I am going to share golden tip for this topic. So let's move on further. What are the number series problems? As you can see here, few examples are mentioned. So these are the series of numbers, as you can see here in the first example: 2, 4, 6, 8, 10, and then question mark. So here by logic, I guess everyone can answer that in place of question mark the answer must be 12, that is even numbers in series. In case of second example, as you can see, 2, 4, 8, 16, 32. So here we are doubling the numbers, right? So after 32, in place of question mark, the answer must be 64. Next, in this case, 4, 9, 16, 25, 36, 49. These are the number series. And what will be the in place of question mark? If we observe these numbers, 4, then 9, then 16, and so on, all these numbers are squares of some number. For example, 4 is a square of 2, 9 is a square of 3, 16 is a square of 4, and so on. So 49 is also a square of 7, and in place of question mark there will be a square of 8, that is 64. So 64 is the answer in case of third series. And in case of fourth series, this is a special series, and here if you try to find out a logic, I guess you may not get that logic very easily since it is a special series. Those learners and students who are practicing number series topic and problems, those only can be able to solve this. So my request to all the viewers will be, pause the video and try to solve this. Try to find out what will be there in place of question mark. And once you are tried for this, if you got the answer, that's very good. If you didn't, no worries. We are going to talk about the golden strategy, golden tip, how to solve the problems of number series. So my request will be, go through the video, watch the video fully. Now in this case, these numbers are 7, then 11, then 13, 17, 19, 23, 29. So if you carefully observe these numbers, all these numbers are prime numbers. So prime numbers are basically the numbers by those numbers will not have any factors, as well as those numbers we cannot divide further in a whole number. So 7 is a prime number. After 7, 11 is the next prime number, then 13 is the next prime number, 17, 19, 23, and 29. So these prime numbers are in series. So after 29, the next prime number in place of question mark is 31, and that is the answer of this question, number series question. Now let's go to the next part, types of number series problems. So before starting with number series, you should know what could be the different types. So this is the first type. In this, the question mark is placed at the last, and we have to find out what will be the number in place of this question mark. In the second type, the question mark may be placed in between. So that is the next type. Further, there will not be any question mark in this type, but there will be a wrong number placed in place of any number. So here, if you observe this series, first number is 2, then 4, then 6, 8, 9, 12, and 14. So if you observe it, there is a difference of 2 between each number, but in case of this 8 and 9, there is a difference of 1 only. So we can conclude here that this 9 number is a wrong number. This is odd one out or wrong number. So this is how this type could be. Next type of number series problem could be a combination of numbers and alphabets. A2, B4, C6, D8, E10. So obviously next number will be the letter which is after E. So after E, F is the letter, and after 10 the even number is 12. So F12 could be the answer in place of question mark. And the last type could be only alphabets. That also can be the series like this: A, B, B, C, C, D, D, E, F, and next will be F, G. In place of question mark, F, G could be the answer. So these are the types of number series. Now let's move on to the strategy. Now this slide is very important as far as if you are trying to command over this topic, number series topic. Now in this, on this slide, these steps are mentioned: step 1, step 2, step 3, step 4. So whenever you are solving a number series problem, just try to follow these steps and very easily you can come with the answer. You can find out the answer. Okay, so we will see these steps in detail. Step 1 says that whenever you read that number series problem, then check for prime numbers. So those numbers, if are the prime numbers or related to some calculation related to prime numbers, then try to apply that logic to solve the problem. If those are not prime numbers, those are not related to prime numbers, then next step you can check for differences. Now whatever problems I have seen in the topic number series, majority of it, 70-80% of the problems will get solved by this single logic of difference. So this is very important part of the strategy. So second step is try to check the difference between those numbers, series numbers. Then if that is also not working, then you may go for next step. Next step is about checking for multiplication or division logic. If that is there, you can check for it. If that is also not working, if you are not able to get answered by this also, then go for step 4, that is check for squares, cubes, or square roots and cube roots. That also could be the logic. If that is also not working, then check for alternate number series. Alternate number series is alternatively the logic you can apply. During practice we will see problems based on this also, so that you will be clear on it. And the last one could be combination of above logics. That may also happen. So whenever you are trying to solve a problem on number series, my suggestion will be try to implement these steps and try to find out the answer very easily without any headache. Okay. Now further, it's time to solve the number series problems on whiteboard. So we will go to whiteboard now. So here we are on the whiteboard, and on this whiteboard you can see we have three questions: question 1, 2, 3, and here we have our strategy to solve the number series problem. Step 1, check for prime numbers. Step 2, check difference. Step 3, multiplication or division logic. Step 4, squares, cubes, square roots, cube roots, etc. Step 5, check for alternate series if any. And step 6, combination of above. Okay, and whatever examples we are going to see here, those will be either low difficulty level or medium difficulty level or high difficulty level. Okay, so all three types we are going to see. Now these are the low difficulty level questions: question 1, 2, 3 till 6. We will be having low difficulty level questions. Let's try to solve the first question, question 1. So here in this we have 8, 12, 17, 23, 30, and next number is question mark. We have to find out what will be the number in place of this question mark, right? So looking at it, let's try to apply the strategy. So check for prime numbers. Are these prime numbers? 8 is not a prime number, 12 is not a prime number, 17 and 23, these both are the prime numbers, and 30 is also not the prime number, right? So prime number logic cannot be applicable here. check for differences. Let's go for differences now. So 8 and 12, the difference is 4. 12 and 17, the difference is 5. 17 and 23, the difference is 6. 23 and 30, the difference is 7. So if you observe the differences, it is incrementing by plus 1. 4, 5, 6, 7, and next difference should be 8. So if we add 8 into this number 30, we will get the solution as 38, and that is the right answer for question number 1. Okay, let's go for next question. Question number 2. In this we have 72, 63, 54, 45, and then question mark. Now check for prime numbers. 72, 63, 54, 45. No, not a single is a prime number. Check for differences as per step 2. Check for differences. 72 and 63. The difference is how much? 7 and 2. 9 is the difference. 63 and 54. The difference here is again 9. 54 and 45. The difference is again 9. So every time the difference is going to remain same, that is 9, and next number will be 45 minus 9, which is 36, and that is the right answer, 36. Now let's check for question number 3. I hope now you will like to solve this. In question 3 we have 1, comma 8, comma 27, comma 64, comma question mark. Now pause the video here and try to solve this in your rough book. I hope you might have tried for this. Now let's try to solve this together if you are not getting answer. Now here in this series we have these numbers. Let's apply our strategy. Let's go for checking the prime numbers. 1, 8, 27, 64. Obviously these are not the prime numbers. Let's check for difference. In case of difference, here the difference is of 7. Here the difference is of 19. Here the difference is of 47. The difference is of 47. So here you can check 7, 19, 47. So there is no as such logic when we are checking for differences. Now let's go for step 3, multiplication or division. So if you check the series, even multiplication and division, we cannot apply any logic of that. So it might not be that logic as well. Go for next step, step 4, which is squares, cubes, square roots, cube roots. Now if we observe all the numbers 1, 8, 27, 64, all these numbers are cubes of some numbers. So 1 is a cube of 1 itself, 8 is a cube of 2, 27 is a cube of 3, 64 is a cube of 4, and so on. So 1, 2, 3, 4, and each time we have to take the cubes. So next number must be 5 cube, which is 125, and that is the right answer. Here again we have question 4, 5, 6, which is of low difficulty level till question 6. So let's try to solve this. Now in this question number 4 we have 16, 33, 65, 131, 261, and then question mark. Okay. Now again let's go by our strategy. The strategy says that check for prime numbers. These are not the prime numbers, so let's skip that one. Step 2, check for differences. We can check for differences here. The difference between these two is 17. Difference between these two is 33 and 65. So that gives 32. Then 65 and 131. The difference between these two is 66. Here the difference is 130. And next we don't know. Okay, so these are the differences. Now if we observe the differences 17, 32, 66, 130, as such there is no perfect logic in the differences. So we may check for any other step. Let's go for multiplication or division. Checking of that multiplication here 16 and then 33. So maybe we are doubling the number into 2. If we make it, we are doubling the number and then making plus 1, right? That gives 33. 33 twos are 66. So again here we are doubling the number, but this time we are reducing it by minus 1. Then 65 2s are 130. Again here we are doubling but adding one number. And 131, double of 131 will be 262, right? So again here we are doubling and subtracting 1. So if you check, we are doubling the number, adding 1, doubling the number, subtracting 1, doubling the number, adding 1, doubling the number, again subtracting 1. So next will be double the number and add 1 in it. Double of 261 will be 522, 522, right? And subtracting 1 from it, sorry, adding 1 in it gives the answer 523, which is the right answer. 523 is the right answer for this. So the logic of multiplication and division is applicable here. That also you can come to know from these differences as well. So if you check the differences, 16, 17, 33, 32, 65, 66, 131, 130. So from that also you can get some logic if you are very keen observer as well as you have done lots of examples of number series. Now let's go to the next problem, question number 5. Here we have 80, 99, 120, 143 and then question mark. Now as usual, check for prime numbers. These are not the prime numbers. Check for differences. So differences here gives 99 minus 80 gives 19 as the answer. 99, 120. This gives 21 as the answer. Difference of 120 and 143. The difference is 23. And next number we have to find out. So if you check the differences 19, 21, 23, the odd series is going on. We can continue the odd series. So next difference must be 25. So if we add 25 into this, we will get our answer as 168. And that should be the right answer, 168. Now let's check for the last one, 2, 6, 18, 54 and next will be what? Here also check for prime numbers. These are not the prime numbers, so that may not be the logic. Check for differences. Let's find out differences. 2 and 6, the difference is 4. 6 and 18, the difference is 12. 18 and 54, the difference is 36. Right? So that way we are increasing the difference here. But still, if you are able to find out the logic, you may check, or let's go for any other step. For example, check for multiplication or division. In case of multiplication, 2 3s are 6, so we are multiplying by 3. 6 3s are 18, again here we are multiplying it by 3. 18 3s are 54, again we are multiplying by 3. So simply, if we multiply 54 by 3 again, we will get the answer. And that answer should be how much? 4 3s are 12, 2, and 5 3s are 15. So it should be 162. The answer must be 162. Okay. So here we have three more problems, question 7, question 8, 9, which is of medium difficulty level. Now let's try to solve this. So here we have question number 7, which is 8, 12, 18, 27 and then question mark. So we have to find out what will be there in place of question mark. Pause the video and try for this. I hope you might have tried this. Now let's try to solve this together. So for this, as per our strategy, let's try to solve for prime numbers. 8, 12, 18, 27, these are not the prime numbers. So this is not the required logic. Check for differences. In this case, difference between 12 and 8 is 4. Difference between 12 and 18 is 6. Here the difference is 9. And next we have to find out, right? So 4, 6, 9 and question mark. Again, there is not a as such any difference logic in difference. So let's check for any other like multiplication or something. So 8 and 12, we don't have as such the doubling, tripling multiplication. So that is also may not be the right logic. Division obviously will not work. Check for squares, cubes. 8 is a cube of 2, but 12 is not. It's not a cube, it's not a square even. 18 is also not, and 27 is a cube of 3. But these two are not. So that may not also be the logic. Take for alternate series here also 8, 12, 18, 27. As such, there is no any alternate series we can see. Now we have to try for combination. In this case, we have to try for combination. So let's check how we can solve this. So if we observe these numbers very well, we will see that 8 and 14 we are making it half. 12 the difference is 6, 18 the difference is 9. That way the series go on. So if we half the number and then we add into the previous number, we get the next number. Similarly, to this number, if we make a half of it, add it, we get the next number, and so on. Right? So here, 27, half of 27 will be how much? 13.5. And if we add 13.5 into 27, we get the answer as 40.5. And that is the right answer. Okay, so this is how you can check. In case if you search this same problem on internet or maybe on some website or something, you get the multiplication factor here as 1.5. So every time we are multiplying by 1.5, and that is how we are getting the final answer. That is also one of the logic. But when we are trying by maybe using this or on your own, you may not find this multiplication factor directly, but this logic you can obviously get during the practice. Let's go for next problem. Question number 8. The numbers are 61, 59, 53, 47, and then question mark. Again, please pause the video and try for this. So I hope you might have tried for this, and as per our strategy, if we check for prime numbers 61, 59, 53, 47, all these are the prime numbers. So this must be the prime number series. And one thing you can always remember, if you have all the prime numbers in your series, then obviously any logic like differences, multiplication, division, squares, cubes, or maybe alternate series and such things will not work. Only and only prime number logic will work here. So if you see 61 is a prime number, before that, previous to that, 59 is the prime number, previous to that, 53, and before that, 47. So before 47, we have a prime number 43, and that must be the right answer. Let's go for next. Here we have 8, 7, 11, 12, 14, 17, 17, 27. Pause the video and check for the solution. Try for it. I hope you have tried. Now let's try to solve this together. Now if you check, these are not the prime numbers. Few of them are prime numbers, but few are not. So prime number logic cannot be applicable here. So this is not the part. Check for differences. If you check here the differences, the difference is 1. Here 1. Then here we have difference 4. Then again 1. The difference is here 2. Here the difference is 3. Here the difference is 0, and here difference is 5. If you check the differences 1, 4, 1, 2, 3, 0, 5, no logic. There is no logic in these differences. So this may not be the logic for this problem. Multiplication division also doesn't seem to fit here. Let's go for next. Squares, cubes, these are also not the part of the logic here. Alternate series we can check, since these are seems to be very random numbers, even we are repeating the numbers here. So alternate series could be the logic for this. Now let's check. Now in case of alternate series, you can check this, the alternate numbers and difference between these alternate numbers. So here 8 and 11, the difference is 3. 11 and 14, difference is 3. 14 and 17, again difference is 3. So 17 plus 3, that gives the answer as 20, which is the right answer. Okay. Now in this case, we have checked for these numbers, the numbers where I have made arrow 8, 11, 14, 17 and so on. But what about the remaining numbers? We also need to check the logic, some logic for the remaining numbers. So if we check for these numbers 7, 12, 17 and 22, let's check the difference here again. 7 and 12, the difference is 5. I will write it down here. Then 12 and 17 difference is 5, 17 and 22 difference is 5. So after 20 we may have a number wherein we can add 5 into this 22, which gives 27. So this is our answer 20, but after that also we can calculate, and this series will go on till infinity, right? Okay, here we have the next questions 10, 11, 12. So these are of HD, that is high difficulty, and those learners and students who have practice of solving number series problems, I guess for them these will be easy and they can solve. For others, it may seem to be difficult, but let's try for it. Let's try for it. Pause the video and try for this question number 10. Okay, I hope you might have tried this. Now let's try to solve this together. The number series is 201, 202, 204, 207 and then question mark, right? As per our strategy, check for prime numbers. These are not the prime numbers. Check for differences. So here in case of difference 201, 202, difference is of 1. 202 and 204, difference is of 2. Here the difference is of 3 and here we don't know, right? So 1, 2, 3, right? So next difference must be 4. Next difference must be 4, and by doing it we get 211, and that is the right answer. Now you might think that why this question number 10 is from high difficulty level, because when you are not solving this by difference method, and if you are trying it randomly or directly by looking at the numbers, 201, double of 1 is 2, double of 2 is 4, and double of 4 must be 8, right? That way our brain works actually. But if you're trying by that way, you will never get any solution, because here it is 7 and you will get confused. You will start thinking about any other logics, maybe other logics, but you will not find any answer here, and that is why this is of difficulty level, high difficulty level. So if you are trying this by difference method, you will easily solve this, right? So my suggestion will be, in case of number series problems, many of the questions, almost 80% of the questions of this topic, number series topic, can be solved by this single logic, difference method, checking the differences, right? Let's go for next. Question number 11, 60, 45, 58, 43, 56, 41. What will be the next? Pause the video and check for answer. Okay, I hope you might have tried for this. Now let's solve this together. So here we have 60 number, then 45, which is less than 60, then 45 to 58, which is again more than 45, 58 to 43, which is again less than this, more than this, and again less than this. Obviously, our answer will be greater than 41. The answer will be greater than 41, but we don't know exactly what number it is, but it should be greater than 41. That is clear from this logic. Now whenever you see such alternate kind of things, which is reducing, again increasing the number, reducing the number, increasing, reducing, in such case more chances are there that that problem is from alternate series. Okay, so instead of finding out the differences, let's directly come to the alternate series. Now in case of alternate series, here we have 60 and 58. I will again make the arrows here so that it will be visible, clearly visible. 60 and 58, the difference is 2. 58 and 56, again difference is 2. So here by this logic, if difference is again 2, we should get the answer as 54. We should get here the answer as 54. Now let's cross check whether this is perfect by checking the logic of remaining numbers. So remaining numbers are 45, 43 and 41. So 45, 43, the difference is 2. 43, 41, again difference is 2. And yes, this is the logic perfect. This logic is perfect. So after 54 also we have another number which can be taken as after 41, it will be 39. So 54 is our right answer, and after 54 also we have 39, and so on we can go by reducing the numbers. It may go in negative side also. That doesn't matter, but the series is infinite. That is the main point here. Okay. Let's go for the last problem of this video. So we have 7, 26, 63, 124, 215, 342, and then question mark. Let's pause the video and try for this. Now let's try together how we can solve this. So checking for prime numbers, obviously these are not the prime numbers. Step number 2 is checking for the difference. Now let's go for the difference. Here 26 and 7, the difference is 19. Then 26, 63, the difference will be 43, 40 and 37. 37 will be the difference. 63 and 124, the difference will be around 60, 64 and 61. Then 124 and 215, the difference will be almost 80, 76 plus 15, 91. 215 and 342, the difference will be 100, and 42 minus 15 will be 32 minus 5, that is 27, 127. So these are the differences. In this case, 19, 37, 61, 91 and 127. So again, we cannot find any logic as such here, and that's why we will not go for differences. Let's check the other logic, multiplication or division. So checking for multiplication and division, here 7 2s are 14, 7 3s are 21, but that is also not as such working, right? Go for squares, cubes, etc. Now 7 is a prime number, it is not a square or cube of any other number. 26 is also not a square or cube of any number, and so on. Then alternate series, that is also not the case here. You can check for it. But 7, 26, 63, 7, 63, 215, that also doesn't seem to work here. We need to go for combination. Combination we need to check. Now if you observe all these numbers, one by one, 7, 26, 63, 124, all these numbers are very close to figures like 8, 27, 64, which are perfect cubes of some number. For example, this is a cube of 2 minus 1. That could be the logic. 26 is a cube of 3 and minus 1. 63 is a cube of 4 minus 1. 124 is cube of 5 minus 1. 215 is cube of 6 minus 1, and 342 is cube of 7, sorry, cube minus 1. So this seems to be the perfect logic. Obviously our answer will be cube of 8 minus 1, which is 511. 512 is cube of 8 minus 1 is 511, and this is the right answer. So this way we can solve the problems by using these strategies. Okay, so I guess enough number of examples we have taken here for this video. Now we will move on to the next part of the video, last part of the video, which is golden tip. So after solving many problems, here we are again on the PPT. So here I am going to share a golden tip for this number series topic. So we already have seen steps to solve the problems, and according to those steps we have solved few problems of this topic, number series topic. Now here the golden tip I am going to share. Always remember this tip whenever you are solving number series problem. This is the golden tip. Whenever you are trying to find out the logic by which you are going to solve the problem, that logic, your logic should be applicable to every number. It should be applicable, it should be perfectly fit for every number of that series. If it is applicable to only few of the numbers, and if any single number or two numbers are not fitting in that logic, then that logic may not be perfect. You may go wrong even if you find the solution in options, but that logic may be wrong and it may mislead you. So whatever logic you will try to apply, you will find that should be perfectly fit for every number that of that series. This is the golden tip. Thank you for watching the video. Just practice a lot and you will be very confident while solving number series problems. Thank you.